Hey everyone, welcome back to the channel. Don't forget to hit that subscribe button for more cool maths videos, and let's dive in. Today we are going to be doing difference of cubes or addition of cubes. Well, to start, what is a cube? A cube is simply any number. For example, take 3, multiply 3 by itself 3 times, and that's equal to 3 cubed. And so that's 27. So 27 is a cube and it is 3 cubed. Other examples of cube numbers are 8. 8 is 2 times 2 times 2, which is 2 to the power 3. Other cubes that are commonly tested are 64, which is equal to 4 cubed, and 1, which is 1 cubed. I have noticed a trend that a cube number is a power of 3. For example, 27 is 3 cubed, 8 is 2 cubed, and 1 is 1 cubed. So as long as you have a power of 3, it is a perfect cube. So numbers are not the only things that can be cubes. We can also work with variables. So examples of variables that are cubes are x to the power 3, y to the power of 3, x to the power of 6. If you have any power that is divisible by 3, then the variable x to the 6 is a perfect cube. So that's not the only case. You might have examples of combinations of them. For example, we know 8 is a perfect cube. We also know x to the 3 is a perfect cube. 8 is 2 cubed and x is x cubed. Therefore, 8x cubed, which is a combination of 8 multiplied by x cubed, that will also be a perfect cube. Okay, now that we know that a perfect cube is a number times itself 3 times, or any variable that has a power of a multiple of 3, we can now go on to the rule a cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. We also have a rule for addition of cubes. A cubed plus b cubed equals to a plus b, a squared minus ab plus b squared. How can we remember this rule? Well, notice that the negative sign stays there, the positive sign stays there. So your first bracket is always either a minus b or a plus b, and that really depends whether it's a cubed minus b cubed or a cubed plus b cubed. The next thing to note is that the a squareds, it's always a squared plus b squared. That is not going to change. Okay, so a squared plus b squared. So what's an easy way to remember these rules? So I'm going to write it down here. If we have a cubed minus b cubed, you can start by saying a minus b. So you drop the cubes. That's your first step, is to drop the cubes. Then you may add in squares, so a squared plus b squared. So if you have a cubed plus b cubed, you'll follow the same steps. You'll drop the cubes first, so it will become a plus b. Then in your next brackets, it's a squared plus b squared. Now we just need the middle term, and the middle term is, if that is a minus, this becomes a plus ab. So you switch the sign. If that's a plus, this becomes minus ab. And that's how you learn the rule. Let's try to solve some questions with the rule. So I've pulled together some questions from past year papers. So this is the level at which you will be tested in grade 10. Let's start with x cubed minus 8 cubed. So this is definitely difference of cubes, because the 3 should give us a hint that it is going to be difference of cubes. Let's recall our rule. A cubed minus b cubed is equal to a minus b into a squared plus ab. We switch the sign and then it's plus b squared. Okay, Now that we have our rule, let's apply it. In this case, a is equal to x, and 8 is equal to 2 cubed, therefore b is equal to 2. Another way to determine what's the cube root of 8 is just to say cube root 8 and you'll get 2. Okay, so that's how you can determine if a number is a perfect cube as well. Just take the cube root. Let's use the rule now with a equals to x and b equals to 2. Therefore, x cubed minus 8 is going to be equal to, instead of a, we're going to write x. Instead of b over there, we're going to write minus 2. Then it's going to be a squared, which is x squared, plus a is x, b is 2, so x times 2, plus b squared, which is 2 squared. Now we can neaten this up, so we'll end up with x minus 2, x squared plus 2x, and 2 squared is plus 4. And that's it. Let's try the next question. Now I know this is addition of cubes, so let's try to recall our rule. A cubed plus b cubed is equal to, so we can start by dropping the cube, a plus b into a squared plus b squared, and then we swap the sign for the middle term, so this will be minus ab. In this case, we know definitely x cubed is a perfect cube, but what about 125? To check if 125 is a cube, we take the cube root in our calculator of 125 and we get 5. Therefore, this term is the same as 5x cubed. 1 is the same as 1 cubed, so it's plus 1 cubed. So when we're substituting into our formula, a will be equal to 5x and b will be equal to 1. So if we plug it into our formula, instead of a, we're going to have 5x plus 1. Instead of a squared, we're going to have 5x squared minus a is 5x, so I'm going to keep that there. B is 1 plus b squared is simply 1 squared. I can simplify this further. 5x plus 1 into 5x squared is 5 squared. If you put that in your calculator, is 25. So that becomes 25x squared. 5x times 1 is just 5x, so it's minus 5x plus 1. And that's your answer. Let's try the next question. 2x to the power 6 minus 8. 6 is a multiple of 3, so that is definitely a cube. If I take the cube root of 8, I get 2. Let's try to take the cube root of 2. And what am I getting? It's 1 point something. That means 2 is not a cube. Does that mean we are unable to solve? No, that does not mean that. Because we notice that 2 and 8 have a common factor, which is 2. So in order to solve this question, the first thing we're going to do is take a common factor. So it's x to the 6 minus 4. Okay, are we done here? No, because this can further be simplified using difference of squares. X to the 3 minus 2, x to the 3 plus 2. Can this be simplified using difference of cubes and addition of cubes? Well, let's try again. The cube root of 2 is 1 point something. Therefore, this is not a perfect cube. And so then we cannot use difference of cubes any further. Remember, we factorized here using dots or difference of squares. You can watch my previous video for how we do difference of squares. But in terms of using difference or addition of cubes, we cannot use it in this case, and so we are done at this step. So you won't be able to apply difference of cubes or addition of cubes in every question, so you must also be aware of that. Let's look at this question. So it's a combination of multiple factorization methods. For the difference of squares, please watch my previous video. In the top, we see an addition of cubes. So just to recap, let's just write down the rule. a cubed plus b cubed is equal to, we drop the cubes, so it becomes a plus b, then it's always a squared plus b squared, regardless of whether it's a cubed plus b cubed or a cubed minus b cubed, it's always a squared plus b squared. The sign in the center, we must swap it with this, so if that's a positive, this should be a negative ab, and so that's our rule. So let's factorize the top part. P cubed plus q cubed is going to be p plus q. So here we're just swapping a with p and b with q. So this becomes p squared minus pq plus q squared. So here we just swapped, p became a and q became b. So we just swapped a and b with p and q. Okay, let's continue. So that's the first bracket all over p squared times, let's take out 3 as common factor, so we'll have to p minus q if we take out 3 as common factor, and the bottom is difference of squares, so it's p minus q, p plus q. Now we can cancel terms out. P plus q cancels with p plus q, p minus q cancels with p minus q, so we just have 3 times this bracket. We can write the 3 first. So it's 3 into p squared minus pq plus q squared all over p squared. And that's your final answer because you cannot simplify further. Thank you all for watching this video. Hit subscribe button for more videos in